Alright, in this video we're going to be talking about how to graph quadratic and absolute functions when given transformations. So like the quadratic or absolute value function has already been transformed and we're going to graph it. I'm going to show you how you can do this without a calculator and also how you do it in a calculator. So for the first one, you could think about your vertex, that point that's going to be on the axis of symmetry that kind of splits this down the middle. That's going to be the same. So as we did before, you can say the middle of this graph is going to be where this is and where this is. You're going to take this and flip it. So that middle point is going to be at 1. So when I say flip it, I mean the sign. Instead of it being negative, we're going to be positive 1. And then 2. You could also think about this. Your parent function was at 0, 0, and now it's been moved to the right 1 and up 2. It has not been stretched or compressed, so the scale has not changed. Previously, your parent function, the scale was just 1. And because it's the absolute value, it's 2 linear lines with slopes of 1 and negative 1. So from here, I could go up 1 to the right 1, up 1 to the right 1, as many times as possible. And then the same thing. Well, I only need 5, but you can, for absolute value, you can always do more. And then I can go up 1, left 1, up 1, left 1, up 1, left 1. So this should be my new function, and I can put this in just to double check. So y equals alpha window to get my absolute value, x minus 1 plus 2, I think that's what it was. Yeah. Can I graph it? And it looks like that. And if you're not sure, you can always go into your table and compare your points. So we started off with 1, 2, and then went 2, 3, 3, 4, 4, 5, 5, 6, and then the opposite way, 0, 3, negative 1, 4, negative 2, 5, and so on and so forth. So a lot of this you can do without your calculator, but again, you will have your calculator to check yourself. For number 2, your vertex would be at negative 3, and there's nothing on the outside, so it would be 0. Now this one is being vertically stretched by a scale of 2. So you kind of have to think about, okay, what were your y values before? And I'm just going to make this a small table of your parent function, x squared. You had negative 2, negative 1, 0, 1, 2, and then 4, 1, 0, 1. So now, taking those those y values, we're going to multiply those y values by 2. So instead of 4, this would be at 8. So it would be at it would still be at 8, but it's been moved to the left 3. So if I go 2 from that and go up 8, right up here. 1 times 2 would give me 2, so 1 to the left of this vertex point. Instead of up 1, I'd go up 2, and then it should follow on the other side. And this looks like it's been vertically stretched and moved to the left 3. But let's double check it just to make sure. Yes. And when I look at my table, I have negative 5, 8, which is that's what I'm at. Negative 4, 2, which is what I'm at. Negative 3, 0, which is my vertex. Negative 2, 2, which is right. And negative 1. So again, you could do that without the calculator, but it's there if you need it. Now this one, for number 3, our vertex point, we don't have something on the inside, so that would be 0 and then negative 4. This one's kind of easy because the only other thing, we can tell it was shifted down 4 by the 0, negative 4. It was also flipped upside down. So instead of it going up, it's going to go down. So instead of it having that positive, and it'll still have a positive and negative, so they'll just be opposites. Now it'll go down 1 to the right one, and down 1 to the left one. And just to double check, there's our graph, there's our table, and as you look and see, those points do match. Okay. Number 4 is really easy because it's taking your parent function and it's just moving up 1. So instead of 0, 0, it would be at 0, 1. Instead of 1, 1, it would be at 1, 2. Instead of negative 1, 1, it would be at negative 1, 2. Instead of 2, 4, it would be 2, 5. And instead of negative 2, 4, it would be negative 2, 5. So that one we don't need to check because we didn't really do anything to the current function except move it up 1. But you could check it, just to make sure. Then the next one, we are moving to the left 3, so our vertex, and I don't think I did this, but our vertex for this one would have been at 0, 1. For this one, our vertex is going to be at 3, 0, because it's moved to the right. Because this is vertically compressed by 1/2, instead of your slope, because it is an absolute value, going up 1 to the right 1, you're going to go up 1 to the right 2, so that makes it a little easier. And then you can do the same thing on the other side. Up 1 to the right 2, or to the left 2, sorry. Now, I could keep going up and left on this side, but I want this to match on both sides, so I'm going to stop there. And I'm going to graph that one just so you see that that works. So 1/2 times the absolute value of x minus 30. And I can see it's gotten wider and it's been moved to the right. When I go to my table, now some of these points are halves and I'm not looking at all of those, so I need to compare the ones I have. So starting with negative 1, I have negative 1, 2, which is right, and then I have 1, 1, and then we have 3, 0, and then we have 5, 1, and then 7, 2. So that works. For this last one, it's just taking the parent function and flipping it upside down. So the vertex would then, for this, would still be 0, 0, But now instead of 1, 1, it's going to be 1, negative 1. Instead of negative 1, 1, it's going to be negative 1, negative 1. Instead of 2, 4, it's going to be 2, negative 4. Instead of negative 2, 4, it's going to be negative 2, negative 4. And again, you can check that if you so wish. I'm not going to because I know we did a lot of the transformation stuff before. So now you have time to go and practice. Let me know if you have any questions.